science. So I'll also post this later on for anybody who can't watch it live now. But I want to discuss with you today, in this beautiful spring day, a concept that many pupils find to be quite an abstract concept. And that's the concept of monoclonal antibodies. You may remember from your lessons that monoclonal antibodies are just normal antibodies that can help with an immune response, but they've been specifically produced by scientists in a laboratory. And the way they do that is to take a specific antigen, something they're interested in, something that may be causing you an immune response, inject that into a mouse. The mouse will then have a normal immune response and have white blood cells that produce antibodies. Scientists can harvest those white blood cells, combine them with a tumour cell to make a hybridoma cell. And that hybridoma cell can produce the specific antibody to whatever antigen you began with. But also the tumour cell and the hybridoma cell will have the characteristics of a tumour cell, so it can reproduce rapidly. So if you clone that hybridoma cell, you'll have millions of cells all able to produce the antibody which will attach onto the antigen that you want. Now, as I said at the beginning, this is often an abstract concept until you come across things like this. Now, this is actually a box of monoclonal antibodies. They come in an injection form like this that will then be injected into the patient, and they feel quite cold to the touch because they've been kept in the fridge. And the reason for that is, like all antibodies, monoclonal antibodies are proteins, so at higher temperatures they will denature. So I've got sitting with me here a thermometer, and I'm keeping an eye on the temperature. Currently 21 degrees. If we approach 30 degrees, I'm going to put this box back in the fridge to ensure that those proteins do not denature. So what are these particular monoclonal antibodies designed for? Well, they're designed to help people with eczema. So in terms of eczema, it's a skin disease, and it can be an allergic reaction to either something in your body or something in the environment. So scientists have figured out for this specific patient which particular antigen is causing this allergic reaction, this eczema. They've taken that antigen and injected it into the mouse. They've then removed the white blood cells from the mouse that will produce the antibody that attacks that specific antigen. They've combined that white blood cell with a tumour cell to make the hybridoma that can then be cloned. And then that cloned hybridoma, literally millions of them in the laboratory, they're all producing these antibodies that can then be extracted, purified and harvested and placed into these syringes that the patient can then take. Now, one of the things the patient has to check is this little section here, make certain it's nice and clear, and that again tells you that the monoclonal antibodies have been kept at the correct temperature and that they have not been denatured. And again, just to remind those of you who've just joined me, that's why I've got the thermometer. I am constantly checking that temperature to make certain that these do not become denatured, because that process is an incredibly expensive process. Depending on what type of monoclonal antibody has been produced, a single injection can cost hundreds or even thousands of pounds. This is something the NHS is keen to monitor and make certain isn't wasted. But luckily here in the UK, we do have the NHS, so you can have this at a relatively low cost for you, the individual, because your taxes over your lifetime have gone to the NHS. So just once again, we're looking at actual real monoclonal antibodies, and these have been produced to combat eczema in a particular patient, somebody I know. So an abstract concept in the classroom, in your lifetime, these kind of treatments will become the norm. There's a lot of these abstract concepts that we talk about in the classroom. For example, DNA sequencing is another example, and they're fairly cutting edge and new science. But as you grow older, as you become adults and maybe have children yourselves, this cutting edge science will become normal procedure for most clinical issues that you may come across for yourself and your family. Well, thank you very much for watching. Comment, like, post, subscribe, etc. and enjoy your day.